Hello and welcome back to week 6. I'm grading your proposals. It's going to take a while because I really do want to spend some time and read them and evaluate them and provide valuable comments. So just give me a week or two. I'll get the grades back to you. This month's project is a data analytic, a data set that you're going to analyze. I'll break you up automatically, or Web Campus will break up automatically into small groups of I'm open if somebody wants to email me, but I'm thinking 2 to 3 people. Generally, that's a good sized team. So 2 or 3 people, hopefully you all contribute equally. If you have a problem with a member in your team, you got to email me. It happens in real life. We always have problems with team members over time, and it just happens. So if you do have a problem, email me. We'll figure it out. In a nutshell, I just want you to do some analysis or some data, and you go from there. I'll post more information on the data analytics page later today or tomorrow. So last week we talked about Python as a tool to do EDA and other things. I mean, the Python, or sorry, the PDF report, the demo code, that really wasn't EDA. That was just traditional reporting or traditional business intelligence. This, I don't know if this should be called EDA and visualization, or EDA and statistics, or what. Because some advice that I got a while ago was that this person was telling me I wish I had taken more statistics classes. And it's true. Even me, I wish all the time that I've taken more statistics classes. Now, why? Statistics is what machine learning is. Statistics is what business is. Statistics is reality. Whether we like it or not, we are a statistical processing machine. So where our brains work is simple statistical methods compiled millions of times, billions of times. So we are statistical machines. The world we live in is a statistical analysis. And those that are more successful in life, in business, generally can use, even if it's not direct statistics to help them advance. The problem is that when you have a manager or an executive or a person in leadership that doesn't necessarily understand statistical methods, it's hard to inform them of a problem that is only a statistical problem. Okay, I'm going to cover p-value a little bit in this discussion. P-value is a really big one. Often people misunderstand p-value. Some of you are reading this week. Matter of fact, you have not a lot of reading. I put a lot of extra links in there to explore. Because EDA can mean a lot of different things to a lot of different people. To me, it means, hey, you understand the pros and cons of the data set you have. You understand where some of the problems are. You understand where the strength of the data set is. Statistics, to me, is that you're using the right test to answer the right question. And visualization is the idea that you can see either statistics, the data, you can see something that has some type of value to you. So a real quick update, which is a good point. Next week is the midterm, which is just me talking again. It is ethics, which is appropriate because one of the best ways to lie to people is statistics. Statistics is used to lie to people all the time. I probably could Google right now and find 100 different examples of how statistics in mainstream media, CNN, Fox News, USA Today, all these places use the White House, Congress, everyone uses statistics in some ways to lie or to enhance the story. Okay, so far what we've covered is SQL, how to basically access the SQL database, how to kind of make a rough visualization Tableau, how to use Python to do a visualization, or how to use Python to do EDA, which we'll cover a little bit more this week. So now we want to refine our skills a little bit. We want to be able to understand the statistical underpinnings, at least a little bit, of what we're looking at. Did I put? I don't know if I put it in here or not. So real quick, there is a book. Actually, I do. I have it here. I do. Look at this right here. This book right here. Now this is related to R, but the concepts are the same regardless. And it's actually a pretty good book. I've heard from other students that they love this book. Andy Fields. He writes a couple other books. Let's see if I can find him here real quick. He's a professor of child psychopathology. But the thing is, his writing style is very easy to read. Let's see if I can find any of his other books. He has a few other books. I have another one of his books over on my bookshelf. This one, I think, is the other one I have. So if you're having problems with statistics, I'm not asking you to know every type of statistics, every type of test, everything else out there. So I don't know them all. I did a paper just recently, and we went into a real heavy distribution of gamma distribution. And I had to have a refresher myself on, when is gamma distribution appropriate in time series. So, but you have to understand the assumptions of certain statistical methods. You have to understand when statistics is used appropriately and when it's used inappropriately. So let's see. I think it's covered most of what we are. So at the end of this lecture and this demo, basically we've done most of the reporting, most of pulling the data, most of the getting data. From here on out, I'd like to focus a little bit on Tableau a little bit more because some of you want to learn more about that. But I want to kind of focus on machine learning because machine learning in many ways is this black box. And what happens is that with machine learning, people say, hey, I did machine learning, and people just either automatically trust or automatically don't trust this. And as a business expert, a business intelligence analyst, you need to be able to say, hey, that's a wrong type of machine learning. That's a right type of machine learning. And even if you say, hey, that's not right, I don't know what is right, even to be able just to flag something as not right is valuable. Okay? So I wanted to see what this article was about, which I'll share here in a second. So EDA, exploratory data analysis. It's the fundamental idea that we have some type of data set. We probably didn't create the data set. We probably didn't build it or anything else. We probably are given some type of data. Now we need to understand, is that data, what's the quality of that data? If we were to buy a used car, you would look at the quality of the car. Does it have rust? Does it have four wheels? Do the brakes work? Does the AC work? Well, those are easy because we can physically walk up to the car, we can touch the car, we can interact with the car. With data, this becomes a little bit harder because how do we know if the air conditioning works related to a data set? How do we know if the brakes squeak? How do we know if the paint is really bad? Well, this is what EDA does. EDA, we kind of start interrogating the data a little bit differently, and we do that through different tools. Some of them I went in last week's demo, and it is vital because what happens often, and I still do it, a lot of people do it, everyone does it, is we just go through the motions and we don't really interrogate the data enough that we just push forward bad data. Now, there's another saying too that if we interrogate the data enough, it will give us the answers we're looking for. That means that you can't cherry pick the data. So there's that balance between kind of looking at the data and trying to understand it versus just slicing it and cutting it and just making it just what you want. Let me switch over to this article right here. Okay. Yeah, with data growing in large amounts from day to day, it's vital that we understand and make proper use of that data. Yeah, they're talking about R, Python, BI tools like Tableau, Quick, MicroStrategy, a bunch of them. Always ask the right questions, and I cannot stress that these enough right here. I remember why I put this article. So if we're looking for the age distribution of our passengers, because we want to market to a certain demographic, that data set that we had last week, the airline flight one, would be horrible to use. If we're looking for the most common ways to improve productivity, and we're only looking at certain employees, that might not be right. So always ask the right question. This gets back to the statistics also. Always make sure we use the right type of statistical test to interrogate the right question. Have basic knowledge about the problem domain. I'm going to show you a couple of examples of this in a minute or two. But at my job, to do any type of research or to publish or anything, you need two people, a medical doctor and a full data scientist. And they do that because they want people to understand the medical domain and the statistical data domain. And I have a great example of this, two examples. But yeah, never forget your objective. Okay, so let's keep going on. This article talks a little bit about different visualizations, different types of plots that are common. Yeah, so again, last week in the demo, I showed how why YADA profiling or PANAS profiles can do this. It's, hey, is this residual sugar related to density? Is pH related to density? And so it looks at things that are highly correlated. Fixed acidity and density. A violin plot is basically very similar to a box and whiskers plot. I don't know if they have that one above or below. Kind of like this. It's just a different visualization, but I tend to like these a little bit better, as long as you're working with normal data. So let me get back to this. So again, EDA helps to visualize your data. What it is not, and what a lot of people think it is, mindless calculation statistics, creating pretty graphs, reporting the obvious. Something's obvious, a lot of times we don't need to report on it. What it is, calculating interpretation of statistics, creating graphs that help you really understand your data set. I mean, when I hit that airline data set last week and I looked at all the flat age, the distribution of the age, I was like, what's going on here? I thought something was either wrong with my computer or the methods I was using. I tried another I tried another plotting program. And then I looked at a second variable and I realized it's the data set. It's not me. So that is, creating graphs. I created a graph to help me understand my data set. I realized that my data set is just fictional. Okay. Here's a great example of that. Well, EndNote is a program that is a citation manager. So EndNote goes out to the internet somehow and does all this magic stuff, and it creates a citation for a paper we're working on or publishing. Now let's look at this. It shows that the same paper comparing receipt of prescribed post-acute home health care, comparing receipt of prescribed home health care between, same thing. But look at the dates. Look at the dates. This is why we visualize our data. 4/19/23 and 9/14/23. Something's wrong. Somewhere, something got messed up. Not by me, not by something, but some type of translator between PubMed or wherever I got this article from and EndNote messed it up big time. This is why we verify our data. This is why we visualize it. Because if I just said, hey, you have 12 references, that doesn't help. If you have 12 data points, that doesn't help. We need to be able to see things so we can predict problems. Now let's go on here. That article talked about domain experts. Okay, let me pull this up really quick. Okay, when we talk about domain knowledge, this is an example. This is from a paper that we recently submitted a couple weeks ago. And what we're looking at is trying to balance patients using an advanced statistical method. The statisticians, the real geniuses that were doing a lot of the heavy lifting on the statistical part, saw this. They saw rheumatoid arthritis and osteoarthritis. Hey, arthritis, let's just lump them together. They're both arthritises. Both me and the MD I was working with recognize that you can't lump these two together. That would be hypertension is high blood pressure, hypotension is low blood pressure. They're two different diseases, and they're very, very different. Rheumatoid arthritis, RA, is very different than arthritis. And here, let me show you what I'm talking about. Because I spell it wrong. Arthritis is a typical arthritis that we see as people age or abuse their joints. It's a wearing down of cartilage, I believe. Yeah, hip, knees. Yeah, the cartilage within a joint begins to break down. So if you have arthritis, this is mostly what people think about. It's a completely different type of disease than RA. RA is an inflammatory autoimmune disease. Your body attacks itself. RA occurs when the immune system, which normally helps protect the body from infection, attacks its own tissues, causing disease, pain. So they're two completely different diseases. Now, as a computer guy with, let's say, no knowledge of medicine, there's the word arthritis and there's the word arthritis. I'm just going to join them. Both arthritis, boom. Make my life 10 times easier. I'm grouping variables. But as a medical director and as a data scientist actually in this domain area, I know that you can't group these. The treatments are different. The methods are different. How they progress is different. The symptoms are different. They're two very different diseases. So that's why you need both domain expertise, or at least people that have domain expertise, and data expertise. So the EDA process is relatively simple. Come up with an idea. Hey, what's the age of the passengers? What is the top 10 diseases? Start kind of validating or invalidating your ideas. And you'll slowly start to understand your data set. Let's see if I have this there we go. I'll go back to the other one here in a second. Import data set, understand the big picture, preparation, understand the variables. Again, that was a data dictionary. Study the relationship between the variables. That's often done in a correlation chart or a heat map. Brainstorm and start again, kind of. And report and model. Now, the last slide I just skipped over was what I was talking about last week. Do you use Tableau for EDA? And it's funny because Tableau is the furthest program ever designed to do EDA. But yet, look at this. Never is less than all the time. Rarely is less than all these. So the number one answer is sometimes, and that's 200 or 300 people, 657 votes, most of the time and all the time. Why? Why would we use Tableau to do EDA? Because most of the time when we do EDA, we're just trying to understand the data. We're trying to get some ballpark answers. We're not trying to complete the whole pipeline. We want to know, hey, is my age distribution flat like the airline set? Or is it a normal bell curve? Or is it a leading tail? Is it skewed in some way? And Tableau can answer those questions very quickly. So don't think that EDA is solely a Python domain. It's not. Most people, when they do EDA, use Excel, Power BI, Tableau, and if it's some type of weird or exotic data that requires different distributions, yeah, we'll use Python. Okay, we covered those notebooks last week. I'm still really impressed with those notebooks. So, we could spend months talking about statistics. I love statistics, and I can't stress enough the value and how important statistics are to everything that we do in life. I just wanted to access this link really quick. So hopefully everyone's familiar with most of these terms. All these terms: median, max, min, mode, standard deviation, correlation, the tail. So if you have a bell curve, is it leaning one way? Is it skewed in one way? Most of the problems, most of the questions that I see that people have is continuous versus discrete or categorical. The continuous measurement is maybe like back here. It's some type of measurement that it's just continuous numbers. And now it doesn't always have to be. Body temperature is continuous, 98.2, 98.234. Speed can be continuous. Okay, with better tools, we can continue to measure. Now, some numbers are discrete. Day is a discrete, like day is discrete. A blood pressure. So if your blood pressure is 151, they might round it up to 152. It goes into discrete buckets. That's the way I always think about discreteness. It falls into a bucket. Categorical are things that, and I'll cover levels of measurements. Categorical variables are variables that don't, they're not necessarily, it's not that they're not numbers, it's that they fall into categories. Colors are categorical. You can't really say one is better than the other. Those are nominal levels, okay? Actually, let's see if this goes into it. Then if not, we'll pull those up. Okay, let's see if I make this a little bigger. Oh, look at that. So we can actually read it now. Okay, so they're talking about house prices. Okay, so median value of all columns, max, min. We just covered this. A univariate analysis plot, one variable. Histogram, when you look at a histogram, it just shows one variable. Okay, where a scatter plot often shows two. Okay, a box plot. So it talks about and kind of breaks down. I don't know if you can see that, what a box plot contains. The median point, lower Q1 and Q2, the maximum values, minimum values, and the way some programs do a box plot's a little different. So I'll just give you a warning on that. So, but this is just in general. What else do we have? Those violin plots. Removing outliers. For example, price is generally a discrete variable because you can't have half a price. You know, if something is $2.99, it's $2.99. Now, when you charge sales tax on it, it can become a continuous variable because you can keep rounding that number, going out almost for infinity on that. So that's why we use a round function. Well, here's a, no, I wouldn't normally use this heat map. Here's a correlation matrix. All this shows are things that are related to each other. So fireplace and, I can't fall all the way down, year built. So we know that maybe fireplaces were really popular in a certain year. We know that the enclosed porch is not related to the year built. So this is a scatter plot. So earlier I said a univariant, one variant, we're plotting one variable. A scatter plot is bivariable, or there's different terms. Basically, you're plotting sales price versus, I guess, gross living area. We're plotting two variables to see a relationship of the two. Where if we go up here, hopefully we'll have some type of univariant. This is just one garage something. You know, so we're just looking at one independent variable. Let's go back over here. Yeah, and we'll cover a couple more of these here in a second here. Actually, this is fine. Now, I told you I'd cover a little bit of p-value. Okay, I'm going to skip ahead. I just thought about this for 1 second. So I want to show you one thing here. So I included a link to a paper that will probably be required reading. I don't know. So failing grade, 89. Let's think about this. 89. So we can just round up 90% of introduction to psychology textbooks define or explain statistical significance, do so incorrectly. These are generally college textbooks, and they explain statistical significance incorrectly. And one of the things they get wrong is p-value. I've seen it at my work where a manager will run or request some type of p-value analysis for this versus that, and they really don't understand what they're asking for. And it's hard to try to explain to a person, hey, this p-value did reach significance, it did not, and what that actually means. So let me go back to this other ASA. And there's a Nevada chapter of ASA. I think it's $5 or $10 to join. I recommend it. It's a great society, American Statistical Association. So when we start looking at business questions, when we start looking at data science, we want to know, is A versus B? We want to do some type of comparison. If we do nothing, what happens? If we do something, what happens? So we have a null hypothesis. And that a null hypothesis basically says it's no effect. There's no difference between the two. An alternative hypothesis says, hey, there is some difference. Okay? And this is important because remember, we're not generally using population statistics. We're using sample statistics. Okay? What do I mean by that? We're not testing if we do a survey and we survey 10,000 people, but we're going to try to apply that information to the whole population, we didn't get all 330 million Americans. Okay? So we're trying to take a sample and apply it to a population. So when you hear about, I thought I put it in here, it's hard to read. P-values can indicate how incomplete or incompatible the data is with a specific statistical model. Okay, that's an important concept, saying, hey, there is a difference or there is no difference, given that the null hypothesis is true. I wonder if I have, in that article, the 89% of introductory psychology books is a great table. It talks about the most common errors, the most common error found in the textbook. And type 1 error is one of the more common errors, which we'll talk about. P-values don't measure truth. Okay, and also they don't measure effect size. Because something is significant and has a greater or less p-value doesn't mean it's more true or less true. P-value is just one of many measurements. That would be the transparency here. Don't rely solely on p-values. I'm trying to think what other things to say. There's a whole article about this, and it's a good read. Also, I think the APA put out an article about p-value. That's also another great read. By itself, the p-value is not a good measurement for whether or not you should support a hypothesis or a business decision. It's just one of many tools that should be used. However, most people just look at p-value and move on, and this creates a big, big problem. I think we covered, the only thing I didn't really talk about is missing data analysis. I think you understand most of this. Well, I have some pictures here in a second that I can go into this. Missing data analysis. So how to deal with missing data, and it really depends on the nature and the the reason or what you want to do, the domain experts wants to do. Sometimes missing data is just gone, can't do anything about it, and you just have to exclude that whole chunk of data. Sometimes with missing data, you can infer, imputate, guess the data that's missing. Sometimes it doesn't bother analysis at all. If you have 40 million rows and 10 rows are missing, and you're doing an average, it wouldn't, within reason, make a big difference. Okay, so it's really, is the data missing at one particular point? If you notice on that Craigslist car ad, it's missing some data in the very beginning. So, just general terms, normal distribution. And remember too, there are other types of distribution. There's like alpha, beta, gamma. There's a bunch of different distributions. This is just a normal distribution. Right skewed, left skewed, uniform. No age should look like this. Let's see, bimodal. One bimodal, or actually bimodal. This is unimodal. Sorry, I can't think of something else. Bimodal, another bimodal distribution. Now, when we're looking at this, no one of these is right, no one of these is wrong. Okay? And what do I mean by that? So if I'm looking at income, it would be great if everyone's income was like this. We know it's not. We know income is a skewed distribution. It looks like this. A lot of people not making a lot of money, and very few people making a lot of money. Now we translate that to something more important, in my mind, in health disparities. In health disparities, or in social determinants of health, we don't really often care about the people here that are doing fine. We often don't care about people up here that are doing really, really well. Who do we care about? These people right down here. This very first block, or this first block, whatever, however we count it. Why? Because those are going to be your most vulnerable populations. Okay? Think about it this way. If I give you a data set about coffee consumption, how's it going to be distributed? Do we all drink coffee in a bell curve shape? No. There are a lot of people who don't drink coffee. So you're going to have, so I'll go back, something like this maybe. Right? Is rarely bell-shaped. Instead, you follow a right skewed distribution. They have a cluster of values at 0, non-consumers. Another bunch of people who drink low to moderate amounts of coffee. And then you have college students that drink extreme amounts of coffee, or PhD students or master students. So coffee, if I was to see a normal distribution of coffee, I would assume something's up. I would have to reevaluate my data. Same thing here. This is what coffee should look like. This is what drinking should look like. You have a lot of people who don't drink alcohol. You have a few people who drink a lot of alcohol. IV drug users. So always keep how you kind of expect your data to be. Again, actually, let me pull up that article right here. When I first looked at this article, I checked to make sure it wasn't like a July 1st, like an April Fool's joke. I just could not believe it. Yeah, I mean, think about this. Almost 90% of introduction to psychology textbooks, and regardless of what you may think about psychology, I believe, is UNLV's largest graduating major, and it should still be that they use the DSM to diagnose. DSM is Diagnostic Statistical Manual. So psychology should be, at least in the very introduction, adequately and accurately describing statistics, and they don't. 90% of the time, 90% of books don't. And they grabbed 30 books. This is just amazing to me. Where's that chart I was talking about? Look, they're going to make a layer right here. Just a little bit bigger. So here's some of the coding, the errors they found in the textbook. Okay, and Type 1 and type 2 errors are basically when you keep an hypothesis and you should reject it, or when you reject it and it should be kept. Again, different types of statistics, different types of methods, this can be important or it can be unimportant. If you're shipping items that are worth $4 and you ship it to a wrong household, no big deal. Now, if you're doing a cancer screening on a patient and the patient has cancer, an aggressive cancer, and you mark it as they don't have cancer, this is really bad. Okay. So, again, I highly encourage you to take time to look at this article. We'll post it in the module section. But yeah, so that's what I'm trying to at least open your minds to, that 90% of the time people really don't have a basic understanding of statistics. So when we looked at the coffee drinkers, for example, if I want to increase, when we'll talk about this in ethics, if I want to increase the numbers, I had a right skewed distribution, what would I use? Mean. My numbers would be higher. Oh, it looks like more people are drinking coffee. Mode would be, your most common value, which is closer to the end. So this is a way we can lie. And this is a great little link too. So here's a problem. Histogram, well, it says histogram can show outliers, but here, is this just bad data? Did somebody type things in? Is this really the bell curve that we're expecting to see? And this is just a typo? So I looked at a data set similar to this at work, I don't know, 2 years ago. And it had to do with weights of patients. And most of the distribution of weight for patients was, between, 10, 20 pounds and 200, 300 pounds. Nice little bell curve. Then nothing from like 400 pounds up to 2,000 pounds. Then from 2,000 pounds to 4,000 pounds to 5,000 pounds, we had, not some, but we had a significant number of patients. And I know that if a patient weighed 4,500 pounds, the foundation couldn't hold him. He couldn't walk through the building. He couldn't walk. A 5,000 pound patient is impossible. So I knew it was bad data. So that's, some EDA you just visualize and you instantly know, here's a problem. Some of it you just don't know. Again, unimodal, bimodal. Talked about correlation plot. Another term for correlation plots is heat maps. Just kind of show you how things are related. Tableau. In this week's demo, if I can get to work, I tried to redo it and it wouldn't work. I pulled in that Craigslist car set. Okay, and now that I have a minute to talk about it, I can explain why. Last week and this week it says, hey, if you don't have the right question, if you can't define your question in words, no software is going to help you. And so I pulled that Craigslist into the Craigslist car data set into Tableau Prep, which I don't use a ton. And one of the recommendations it gave me was to break off cylinders. Because right now it says 8 cylinders, 6 cylinders. I can't do any math on that. So if I want to know the average number of cylinders per state, I couldn't do that because it's a variable. If I break out 8, 6, 12, if I break out those individual integers to a new column, then I can do analysis on it. And I thought about that. I thought about it over the last week, and I'm like, I was trying to figure out a good reason why I'd want to do that. And it's really hard to come up with a good reason. The only reason you can really think of is maybe you're doing some type of financial analytics for gas or fuel efficiency by state. But I don't know if that's really the best method to do it. I mean, if you think long and hard, you can come up with a reason why you'd want the number of cylinders to do computational work on it, to do an average, to do a standard deviation. But for that data set was designed, or is Craigslist ads, people buying and selling cars. That's where the value of that data set is. It's not designed in, hey, let's do some type of secondary financial analytics to try to estimate the number of cylinders per state. if I had to do that, I would probably use some type of DMV data if I could. Okay, and so Tableau Prep doesn't understand that. It doesn't have a clear understanding of what my question is in regards to that data set. So when it sees that I have 20,000 8 cylinders, 20,000 6 cylinders, 20,000 rows of 4 cylinders, it thinks to itself, hey, let's break this out, just have a number so we can do some cool math on it. And for me, and probably for you, that math is irrelevant. It's a bad recommendation. So I also want to show you a couple more things. I can never spell this site. Okay, I don't know if you've ever seen this site, spurious correlations. It basically correlates two things that aren't correlated. Because if we cherry pick our data enough, and I talked about this earlier, if you interrogate the data enough, it will eventually tell you the answers you want it to tell you. So this looks at the age of Miss America and murders by steam, hot vapor, and hot objects. Correlation is 87%. Total revenue generated by arcades correlates with computer science doctorate award degrees awarded in the US. 98% correlation. So is that saying that we really should open up more arcades? I mean, think about that. To me, that's what it's saying, right? I mean, if we have more arcades, we're going to have more PhDs in computer science. Oh, here, maybe per capita consumption of mozzarella cheese correlates with civil engineering doctoral awards. So I guess really what these two correlations are saying is that we need to open up a lot more arcades and give mozzarella cheese to a lot more people. And we could fundamentally change the American education society, system. No, that's complete BS. Correlation does not equal causation. You'll hear that, and this is what it means. These graphs are what it means. And he has a site in here somewhere that you can go and make your own. But just because things are correlated doesn't mean they're causal in effect. Cause and equal correlation. Like I said, a lot of times non-statistical business managers don't understand this. If people don't understand p-value, they don't understand the basic statistics, they see one thing go up and they see another thing go up, they assume they're related. And as a business intelligence expert, you can never assume that because one thing goes up, another thing goes up. I guess math doctors, we're going to have store more uranium. But if you think about it too, some of these things, uranium stored at nuclear power plants. Do you really ever expect that number to go down? Uranium has like, 100,000 year half-life. So that number is always going to go up. And I bet it correlates with the total number of people dead in the United States. You know why? Because as people get older, they die. And as more people die, that number goes up. So, they're not related. These values aren't related. They're just correlations. They're not causations. So please keep that in mind. I'll get a description of the analytics project, the expectations. I was hoping to get a little bit more grading done. It's due the last day of the month. Happy Halloween. It's a group project. Discussion topic. You guys have been doing great. First reply by Thursday, follow up by Sunday. There's a demo this week, but there's also a little bit more optional reading. It's optional reading. The way I give you time in my head is I just say, hey, if you read half the article, I give you time for that. So that's a lot of extra links. So again, thank you for your time. If you have any questions, please reach out to me. And hope everyone's doing great. Thank you.